Welcome, students. We're going to start a new unit today on solving systems of equations by graphing. This is going to require you to remember all of your graphing skills and pick up a new skill or a few new skills as well. Some vocabulary. A system of equations is a set of two or more equations that are working together. We're going to see that there are three types of solutions for our systems. The most common that you guys are going to run into is one solution. That is when our lines intersect at one point. And the solution set contains only one point. So for instance, this would be an ordered pair like 1, 1, or something like that. No solution means the lines are distinct, so they're not the same, but they are also parallel. And since we know parallel lines never intersect, there will be no solution. This is also called an inconsistent system. So if we look at the red line and the green line here, we can see they'll run on forever in both directions and never cross. Infinitely many solutions means the lines lie on top of each other and are not distinct. They therefore have an infinite number of points of intersection. This is also called a dependent system. We can either write our solution to this as infinitely many solutions, or all real numbers, means the same thing. When using the graphing method, to start, step 1 is to make sure both equations are solved for y. If they are not, then you want to solve for y. Step 2, you're going to plot your first equation on the graph. Step 3, you're going to plot the second equation on the same graph as your first equation. Step 4, find the intersection and determine the ordered pair, so x comma y. And step 5, plug that ordered pair back into both equations to make sure your answer is correct. Let's try an example. Solve by graphing. Y equals 2x plus 3 is our first line, and y equals 1/2 x minus 3. So I'm going to start by plotting 2x plus 3. That means my starting point is 3 on the y-axis, and I'm going up 2 over 1. When solving a system with graphing, your first line you should get quite a few points in both directions graphed. Since we're ultimately looking for an intersection, we're going to see that that's most useful to us. Now we're going to come along and graph the second line. I'm going to use two different colors to show the overlap. So y equals 1/2 x minus 3. That means I start at -3. And since I have positive 1/2, I go up 1 and over 2 in the positive direction. As I'm graphing these, I see continuing in the positive direction is not giving me any sort of intersection, and it's not getting any closer. So I'm going to go back the opposite way. So I'll go down 1 and back 2. And I see that I cross right there. Means this right here is my intersection. That ordered pair is -4, 5, or -5. The solution to my set then is -4, -5. So what's the relationship between the points of intersection and the solutions to the system of equation? They are the same point. Example 2, solved by using the graphing method. If I look at my equations, I see that they are not solved for y right away. So 2x plus y equals 3. I need to subtract 2x from both sides, and I get y equals -2x plus 3. This is now ready to graph. So then I'll go down 2, forward 1. Now I need to solve my second equation, which means I have to subtract x so that I get y equals -x plus 1. This starts at 1 and goes down 1 over 1. And I see it doesn't take long before I have an intersection. And it is located at 2, -1. Now I'm going to check my answer and make sure that this works. So 2 times my x of 2 plus my y of negative 1 equals 3. Well, that's 4 minus 1 equals 3, which is true. So I checked my first equation. Now I'll check my second equation. So 2 plus negative 1 equals 1. 2 minus 1 equals 1 is true, so I checked my second equation, and this is my solution. Try example 3 on your own. Pause the video, unpause when you're ready to check. You should have solved each equation and gotten y equals negative 2/3 x plus 2. You then plotted those. We could have recognized from the equations that these were the exact same line, so our final answer would be all real numbers or infinitely many solutions. Both of these would work. Determine if the solution matches the system of equations. Remember, we used this method earlier to double check our answer. It's good once you're solving systems to check your answer every time. You can guarantee yourself that you get it right as long as you check. If I look at my first equation, 2x plus y equals 3, I'm going to plug in my ordered pairs. So 2 times my x value of 2 plus my y of negative 1 equals 3. That is 4 minus 1 equals 3. So 3 equals 3 is correct. Then I'll try for x plus y equals 1. I'll plug in my ordered pairs. So 2 plus negative 1 equals 1. 1 equals 1, which is correct. So my answer would be yes. That is the correct solution. Now I'm going to try it for b. So 3x plus 2y equals negative 3. And I'll plug in the ordered pair. So 3 times 1 plus 2 times negative 3 equals negative 3. So 3 minus 6 equals negative 3. And I find that it works for my first equation. So I'm going to plug it into the bottom and double check. So x minus 3y equals 6. Again, I'll plug in 1 for x and negative 3 for y. That gives me 1 plus 9 equals 6. 10 does not equal 6. So my final answer for this would be no. That is not the correct answer. Thanks for watching.